For today's Lunch and Learn. With me today is our Director of StorTrends Data Storage, Justin Bagby. He'll be coming along in just a moment or so, but I wanted to address a couple of things before we got started. Number one, if you are within a pizza delivery zone and requested a pizza during your registration, that pizza should be arriving within the next few minutes or so. That is, if it hasn't arrived already. Sometimes the delivery person runs a few minutes late for one reason or another, so just please be patient if they are running a couple minutes late. And if your pizza hasn't arrived by the 1:10 to 1:15 mark or so, that's Eastern time, please shoot me an email. That will be the quickest way to address the issue. My email, you'll see up on a slide here in just a moment, is tylerin@ami.com. That's TYLER. in as in Newberry at AMI.com, and I'll also shoot that across to everybody in just a second here. It'll be up on one of the slides. Second thing to quickly address is please ask questions during the event. We want this to be as much of an interactive experience for all of you as it is for us, so please feel free to shoot your question over the Q&A communicator located at the bottom right-hand corner of your WebEx screen. If you don't see it there, you might have to actually open the panel for the Q&A communicator, and those settings can be addressed at the top right-hand corner of your WebEx screen. But yeah, please ask questions during the presentation, and we'll either get to them back to you via the communicator, or we'll address them on air and address them that way. And finally, if we do happen to experience any technical difficulties during the presentation, these are rare. However, occasionally we will, get some gurgled audio for a second or a distorted screen for a moment. Usually these issues resolve themselves within 10 to 15 seconds, so if we do get a small issue like that, just please be patient with us while we address the issue and get things started. But anyways, other than that, that's all I had for everybody today. It means a lot to us that you're here with us today to learn a little bit more about all-flash storage and what it can do for data centers across the world. So with me, I'm going to go ahead and take the moment to introduce our main speaker for today's event, the Director of StorTrends Data Storage, Mr. Justin Bagby. Justin, they're all yours.
Hey, good afternoon, everyone. Thanks for taking time to join us for this webinar today. We look forward to providing some information on all-flash storage and the benefits that it offers over hybrid storage. So we received a lot of questions from the webinar today, specifically how can you sell an all-flash storage array at the same price or below a hybrid storage array? And that's a great question, and that's where we're going to start with some of the information today. So let's just kind of dive into the agenda here. We're going to go over some introductions real quick. Tyler already told you a little bit about the pizza delivery. If you've got any questions, feel free to voice those through the webinar. We're watching these, so we can field those questions as they come in if we have time. Or you can email Tyler. Like he said, you'll see his email here, and you can contact him, and we'll answer your questions offline. Then we're going to go into understanding the landscape. We're going to spend a few minutes talking about all-flash arrays versus hybrid arrays. We're going to talk about some of the inherent problems with hybrid arrays. We'll talk about the benefits of all-flash SANs, and then we're going to get into where the rubber meets the road. We're going to talk a little bit about the pricing. So we'll show you how we are selling all-flash SAN arrays at the pricing of hybrid SAN arrays and the technologies that we're using to do that and the drive combinations that we're using to mix and match in order to reach those same price points as a hybrid array in today's market. We'll spend a little bit of time on the StorTrends introduction. We'll tell you a little bit about our product, a little bit about our company, who we sell to, how we sell the product, and then I'm going to jump into a live demo. So we'll show you a StorTrends 3600i all-flash array. We'll show you the GUI, talk through some of the features, and then I'm going to show you some of our plugins. For example, the vSphere plugin. We'll talk a little bit about how you can use the vSphere plugin inside of vSphere to manage the storage array, how you can use it to dive into the VMs, and you can kind of get granular there to understand a little bit more about the VMs and how they look and what they're doing as far as performance perspectives to help troubleshoot any issues that you might have of latency or anything like that. And then we'll jump into a summary and a Q&A session. Again, if you have any questions, feel free to raise your hand in the presentation here with that button in the WebEx, and we'll be glad to answer those questions as we go along. So let's get started. So as Tyler indicated, he is our marketing programs manager here with StorTrends. My name's Justin Bagby. I'm a 16-year veteran here at AMI, so I've been here a long time. Started out in the RAID group with AMI, moved over into the BIOS. I've had some remote management and utilities experience from the engineering side, a lot of experience around server DB applications, and now I'm responsible for the business development, sales, marketing, and solutions and support group within AMI for the StorTrends product division. So let's jump right into the meat of the webinar. understanding the landscape, all flash versus hybrid. So I wanted to provide a very simple picture here to make it extremely clear. Most of you probably already know this, but I just wanted to start off the base level, put the cookies on the lower shelf here, and just kind of move up. Hybrid SAN overview. So what is a hybrid SAN? It's a mixture of some sort of flash, usually SSDs and HDDs. The SSDs are used for either cache or tier space, or they could be used for cache and tier space. The SSDs are used to host the hot data. The HDDs, or the hard disk drives, are used to store the cold data. In most hybrid configurations, your SSDs are that's your extremely fast media, your flash. It could be an NVRAM card in the front of the system. It could be a mixture of NVRAM and SSDs. There's a multitude of different architectures out there, and we'll talk about those on another slide here in just a few minutes. The all-flash SAN array, it's all SSDs. There's no spinning disk in an all-flash SAN architecture. It's all SSDs. So if you see the picture on the bottom here, you'll see there's 4 SSDs in the cache area, and then there's 12 SSDs in the tier area. That would be a 16 drive bay appliance. On the top in the hybrid SAN, you see that there's 4 cache drives, or those could be 4 tier drives, and then there would be 12 HDDs, or spinning disk, usually 7,200 RPM slow drives, just thick and slow for storing that cold data. In the all-flash SAN architecture, the SSDs are used for both cache and tier space. So there's not really a divide between media types. It's the same media type. It's flash all the way throughout. So that means that the SSDs are used for hosting the hot data and utilized for hosting the cold data. So as I indicated on the previous slide, not all SAN hybrids are the same. What does that mean? It means that there's a multitude of different architectures that are out there, depending on which vendor you look at. It's not that those vendors were trying to be creative and come up with a differentiating way to hold your data. It's that I think vendors weren't sure how to actually do it properly and effectively in the market to fit all of the different applications. I'm not saying that hybrid arrays are bad. Hybrid arrays definitely have their place in the market, and they're good. It's just at a point now to where the hybrids have definitely been created for specific architecture, specific application deployments in the way that they were created. So let's dive into that a little further. So you hear a lot of the different hybrid SAN vendors talk about caching or talk about tiering. Some talk about both. And StorTrends here at AMI, we actually offer a hybrid SAN array called our 3500i, and I'll show you some slides on that in just a few minutes. But we do caching and tiering in our 3500i array, and I'll go into the details of why we do both. But some vendors deploy the SSDs as cache, some vendors deploy them as tier, and then some use cache and tier. Should you use NVRAM up front, or should you cache everything on SSDs? So some vendors like to use NVRAM because it's closer to the CPU. The unfortunate part about the NVRAM is they're extremely small cards. They're only about 8 gig in size in most typical implementations. So the incoming I/O will fill up that 8 gigs quickly, and then it has to flush downstream to either the SSD cache or downstream to the HDD spinning disk. And then you have a variety of different RAID options. Some vendors use RAID 0 in cache, others use RAID 5 in the SSD tier. So there's a very large variety of different ways to build a hybrid, and these vendors are bringing all those different mechanisms to the market. So why are there so many different architectures? This is something that's kind of puzzled me for a long time. You know, you go buy a Toyota Camry, a Honda Accord, or a Kia Optima, and the features are pretty much the same. They have Bluetooth, they've got backup cameras, they've all got a radio, some have power seats, but the features are pretty much the same, and the engines operate the same. They use the same gas. The only thing that's really different is just the architectural viewpoint, but that's not the case with hybrids. They're architected completely different. So in my opinion, no vendor has been able to really perfect a perfect hybrid to date. So that mixture of HDD and SSD. See, spinning disk was simple, and a lot of you that have been in the industry for a long time, you probably know how easy it was to migrate from one spinning disk array to the other. You didn't really have to think about how much cache space do I have or how much SSD tier space do I have. Do I have to migrate this as a low tier, a high tier? You know, am I going to fill up my SSD space and blow all my hot data down into the HDD tier? There's all these pieces that come into play. So spinning disk was relatively simple. You just, you had a few different tiers. You would tier the data between that, and then you'd send it off either to tape or off-site to back-end disk for storage. So why are there so many of these different architectures? What are the flaws with hybrid storage? This is a slide that consists of the main pain points that we here at StorTrends see from a hybrid storage array. These are not only pain points that you'll see when you purchase another vendor's hybrid array. We've experienced this internal as well. So customers that buy hybrid arrays, they have to experience all of these pieces. And with a flash array, we'll talk about how each one of these changes, how it changes in that game. So first would be inconsistent performance. So there's only 2, 4, 6 SSDs or either a very small NVRAM card in most of the front end of your hybrid arrays. That's where all your incoming I/O is going to sit. It's where a lot of vendors use it to dock that cache. And then the back end cold data is all stored downstream. Well, if your high-performance storage fills up, if your SSD cache fills up, if your SSD tier fills up, whatever that architecture may be, if the NVRAM fills up, there's a lot of flushing going on. There's data that's being pushed down, while at the same time those access blocks are trying to be pushed up. So you're trying to move data in an intelligent way is what your goal is, but unfortunately what you find is that it creates a bog. And inherently what happens is there are read and write misses that suffer. So it's just insufficient SSD space. You occur reads and writes that are misses. That means they go from the SSDs. Those reads and writes are either being written downstream to the disk or they're being read off of those disks. Your applications slow down. You see latency spikes. Your users are going to complain. That's one of the most inherent problems with a hybrid SAN array. It could be from not placing the right amount of SSDs up front. Maybe you engaged with a vendor, that didn't place the SSD size correctly. Maybe they were trying to get inside of your budget and they knew it really wouldn't work. Maybe you just grew too much. Maybe your company had some explosive growth and those 400 gig SSDs that were in there, now you need 800s or you need something even larger than that. So inconsistent performance would be number one. Then growth pains, as I was just saying. You run out of the SSD and flash space, so you're forced to upgrade that SSD cache or that tier. We've heard of a lot of horror stories from other vendors that have sold boxes that were too small originally. Did the vendor have good intentions? Probably. They may have not have had a tool to measure how much hot data you actually had in your infrastructure, but they placed something in there that was too small. Now you have increased unexpected cost. So they hit you up 6 months or a year later for additional sized SSDs, larger SSDs, or another tray with SSDs in it. So growth pains become an issue with hybrid SANs. And then product configuration. So all customers are different. And we found this out in 2013 when we launched our hybrid array. We initially went to the market kind of with the same approach that every other vendor has had that's in the market, where 10% of your data should be on SSDs and 90% can be on spinning disk. But what we learned quickly was that data sets differ. In the spinning disk world, we've been selling spinning disk arrays since 2004. We didn't really have to worry about this. When you run out of capacity, you just add additional disk. If you need more performance, you add another tray of 15K RPM drive disk. You didn't have to worry about how much the customers differentiated in their data sets. But when you only have a specific amount of SSD cache or SSD tier, a very small SSD flash space, you have to worry about that customer's data. You have to understand what it does, how it works. So we had to actually create a tool called StorTrends iData. This tool runs for 7 days in your existing infrastructure. It uses your standard operating pieces from Windows, like we're using WMI and other tools that are baked into Windows if they're Windows servers, the same for Linux. Or if it's virtualization, like if it's VMware, we can actually plug that tool into the actual VM layer and we can monitor those VMs. And what we do during that 7-day period is we watch to see how many hot blocks there are that are coming into the array. So we track those blocks, and then we can come back to you at the end of the 7-day stretch and say, okay, over a 7-day period, you had 2 terabytes of hot data. But you may overall have 40 terabytes of total data in your infrastructure. So you would actually need a 38 terabyte spinning disk and a 2 terabyte SSD. That would suffice you today. And without a tool like that, you're kind of guessing, So what's the proper SSD, HDD mixture? What happens when your I/O application load changes? That tool's great today, but what happens 6 months from now? What happens if you start adding VDI users to this thing? When you add 50 users, it may be okay. When you add 75, you may break it. The load changes at that period in time. So there's a product configuration piece that's hard to understand. It's hard to figure out. And even with tools like StorTrends iData, sometimes we don't understand the full changes that occur because we can't project what those changes are going to be down the road. And then the final piece of this thing is data migrations. This has been a major bottleneck for a lot of customers that have implemented hybrid SAN arrays. Moving data creates these bottlenecks. So in a spinning disk solution, you could move that data from an array to an array. As long as you had space, the performance was the same. So if you've got spinning disk arrays today and you do a vMotion in a VMware environment, it can easily move from a 15K tray to a 15K tray as long as you have the capacity. You don't really have to worry about anything performance-wise. But when you migrate on a hybrid array, again, remember, you only have a very small amount of SSD space. So let's say that it is 2 terabytes and you're going to migrate over a 3 terabyte volume. When you migrate that 3 terabyte volume over, if you don't have the proper pieces in place to move that data downstream and then let it self-promote up, you're going to flood out those SSDs. So all of your hot data now for all your other applications has been flushed down to the HDDs, and all of that 3 terabyte volume, which majority of it's probably cold, is sitting in your SSD space, and it has to now demote. So you get into this demotion, promotion policy issue. You've got to wait for these data blocks to be accessed to promote back up to the SSDs again. It creates terrible latencies. It creates headaches, and you have to wait for the dust to settle, and you have to let these hybrid arrays move their data up and down. Now, in StorTrends, we have some tools baked into our 3500i called tier residency. And what we do is we move that data from an existing array onto our hybrid array into what we call the low tier. That's the HDD tier, so that's the spinning disk tier. And then we'll change that to either a medium priority or a high priority, and then we can turn caching on or off of those volumes. So that helps you get the data up, but there's still going to be delays. That tiering is slow. It takes time for those promotions to occur, and applications are going to suffer and users are going to complain. It's just an inherent problem of having a hybrid array when you're trying to balance it out. So in that 3 terabyte volume that we migrated over, we don't know actually how many of those blocks are hot. We know the size of those blocks, but we don't know which blocks are hot. The application can't tell us that. So we have to promote and demote that data until we get it balanced. And it takes some time to do that, and then that's when the application starts showing latency spikes. So these are the inherent problems that we've experienced and our customers experienced in rolling out hybrid SAN arrays. So we made the decision about 14 months ago that we need to move to all-flash arrays as well. This is for customers that are looking for an easier transition, that are looking for a way to scale the box, and we'll get into the advantages and benefits of the all-flash in just a minute. I just wanted to quickly point out a chart here. This was the storage review that was done. They compared a Dell EqualLogic PS6110, a 6210, the XIOIC box, and then an HP Store Virtual against our StorTrends 3500i hybrid array. So you can see that the Dell boxes are at the top here when it comes to max latency. So these boxes, they go way up in latency when we're running 8K. We're running a write test here. It's 70% reads, 30% writes, 8K block size. So you can see when Storage Review kicked this test off, you see what the Dell EqualLogic boxes did. And then you see the HP Virtual box, it's way up there as well, and it has a severe spike when it gets to the 8th depth of the queue. And then you see the XIO was a little better, but it had a huge gap for some reason between the 8 and the 16 threads. And then you can see the StorTrends 3500. It remained consistent throughout the test. And it beat all of these boxes in this head-to-head performance review that was done by Storage Review. But even with this superb performance out of the StorTrends 3500 hybrid SAN, it still suffers from those items we just talked about on the previous screen. Those are things that a lot of customers can live with. You just have to be extremely organized. You have to plan well. You have to really think about data migration pieces. You have to think about, you have to consciously be aware that you only have so much SSD space and you can't flood it out. Otherwise, you're going to have latency spikes and, your environment's going to be messed up. So let's talk about a little bit about the all-flash SAN problems and benefits. So most people will tell you the first problem with an all-flash array is it's expensive. That's the first thing that you hear no matter what article you read, whether it's Tech Target, CRN, whomever you're listening to. They'll tell you that you're going to break the piggy bank, You see our guy here in the corner with a hammer, he's going to pop his piggy bank, right? That's the number one issue that most people complain about with all-flash arrays. The second thing would be SSD endurance. A lot of customers are worried about will the SSDs run out of program and erase cycles? And in case you're not familiar with SSD, let me kind of give you an analogy here. If you take a piece of paper and you have a pencil, and I have you draw a 0 on that piece of paper, if you erase it and I have you draw a 1, you erase it in the same place, and I have you draw a 2 and you erase it, and this is in the same piece of the paper, once we get to 9, 10, 11, 12, you're going to start wearing a hole in that piece of paper. You can only erase it so many times, and then you're going to have a hole in it. That's essentially the same thing that happens with an SSD drive. There's cells that are inside of that SSD drive, and you can only program and erase those cells so many times, and we call those PE cycles. And those PE cycles are warranted by drive manufacturers with what we call drive writes per day. So you'll hear us talk about a drive write per day calculation, and that's the number of writes that you can create to the drive on a daily basis until those cells start to wear out. A lot of SSD manufacturers, and majority of them, they over-provision their drives. So what does that mean? Excuse me. They'll take a 1 terabyte SSD, let's say, and they'll actually be a 1.2 terabyte SSD. They'll have a 20% over-provisioning factor there. So as those cells start to wear out and those program and erase cycles are dead, those blocks actually change to read-only cells. They don't die, they don't disappear, they don't go away. They just turn into a read-only format. We can't program them anymore. So they become read-only, and then they start dipping into their over-provisioning piece. And majority of the SSD vendors will tell you what your drive writes per day are, and it depends on the storage vendor at that time. How many times are we writing to that device until we wear it out, until we wear out those cells with those program erase cycles? So those are the two inherent problems, and I'm going to talk about how StorTrends solves those two problems in another slide here. So let's take just a couple seconds here and talk about the benefits of an all-flash SAN. Everybody knows about the performance. Superb 1 millisecond performance. You have happy applications and happy users. It's snappy, it's quick, it's fast. So you're going to see a lot higher IOPS than anything you've ever had. You're talking about all-flash arrays that can push from 200,000 to 1 million IOPS. You're talking about the lowest latency you've ever had in your infrastructure. You're talking about a sub 1 millisecond per volume, where in the past, if you've been on a hybrid array, you're in the 3 to 5 range of milliseconds. If you're on spinning disk today, you're probably 10 plus milliseconds on average. The second piece here would be scalability. So you can add databases, applications, and VDI users on the fly. You're no longer worried about the hybrid aspect of it, where do I have enough SSD space to add in these applications and databases and these VDI users. Instead, now you're back to what you were thinking with the traditional spinning disk model. Do I have enough capacity? That's the only question you really have to ask. I've got plenty of performance. I've got 200,000 IOPS. I can go out and add those 100 VDI users that I need to. I just need to make sure that I have enough capacity to add those users. So scalability becomes really simple with an all-flash array. Less downtime. You don't have failing HDDs. There's no mechanical HDDs to replace. So hard drives fail. Everybody knows it. And now you're not worried about the hard drives failing. You have SSDs in an all-flash array. The main thing here, you're just worried about endurance. Is this drive going to last me 5, 6, 7 years? What is it going to look like? How do I measure that endurance? How do I proactively replace a drive that runs out of endurance? And we're going to talk about that, but you don't have to worry about the downtime from failing HDDs. No tiering software. So you can avoid data movement. You can avoid the promotion delays, the demotion delays. We were talking on the previous slide about how you have to move data into the HDD space and then promote it up into the SSD space, and it takes time to do that. It's no longer a worry here. You don't have that tiering aspect anymore. You move the data over, it's on all SSDs. You get SSD performance. So you can immediately recognize and use that data. And then data migration and movement, it's resolved because of all those SSDs. So we don't have to worry about planning for a specific data migration and worried about a smaller SSD block, that could be 1 terabyte, 2 terabyte, 3 terabytes of your total infrastructure. It's an all SSD environment, so we can just immediately move it over. So that data migration and movement's been resolved thanks to the all SSD approach. So we had a lot of questions come in on this. I think Tyler received about 18 or 19 questions on, I'm just not believing that you can provide an all-flash array at the same price point. So let's talk about that. So the StorTrends 3600i, the all-flash array, it doesn't break the piggy bank. So how do we do it? How can we provide an all-flash array at the hybrid same price points? The first is deduplication and compression. So we've architected and designed in a very, very elegant deduplication and compression engine. The typical savings that we see are from 1.7 and up. Compression alone is at a 0.7. So you're going to see a 1.7 to 1 just by enabling compression. The data dedupe piece, it depends on your data type. It depends on your virtualization. How virtualized are you? How many clones of data? How much backup data do you have in your infrastructure? All of that changes the dedupe, or what we call the data compaction ratio. So what we call data compaction is deduplication plus compression. So what we see is the typical IT environment that deploys a 3600 IL flash array achieves a 4-to-1 data compaction ratio. So it means you can take a smaller amount of flash and you can make it a lot larger than it actually is by deduping and compressing that data. So we have a lot of use cases on this. We even have a data analyzer tool, a deduplication analyzer tool on our website, and I'll show you some slides on that in just a few minutes, that you can actually run it on some of your backup data or some of your clone databases, and it'll give you an indicator of what your dedupe ratio actually looks like. So that's the first and foremost piece, is the deduplication and compression that we run in our all-flash array. The second piece is the mixed flash tier. So inside of our all-flash array, we have what we call a WT and an RT, and that's a write tier and a read tier. The write tier comprises of enterprise SSDs. These are your 10 drive writes per day. So these 10 drive writes per day are your very, very, very expensive SSDs. And we'll put around either 4, 6, or 8 inside the enclosure. The bulk of the drives inside the enclosure are our read tier drives. And these are our lower, these are read-enhanced SSDs. They're the lower-cost SSDs. So they have 1 drive write per day. So your question may be, why don't you just put all read-enhanced SSDs in it at 1 drive write per day? The problem there is you're going to hit an endurance issue. And it could be in 18 months, it could be in 2 years, it could be in 3 years. You're going to create so many drive writes per day on that read tier, it's going to wear those drives out. So we use the enterprise class drives as a front-end buffer for all of our writes, and we use the read tier drives for all of the reads. So how does that actually happen? And how do you protect the read tier? So you said read tier drives aren't good. From an endurance perspective, a 1 drive write per day, they're going to wear out. Well, this is where you have to put your innovation, right? And this is what AMI does well. We've been in business for 30 years. We've been a RAID vendor for, 10-plus years. We were the #1 RAID manufacturer in the world in the 90s up until 2001 when we sold the Mega RAID card off to LSI Logic, who's now owned by Avago. If you've ever used a Dell server, an HP server, any of the brand name servers in the world, you've used the Mega RAID card. So we understand data placement. We understand, how you store data. We understand RAID. That has been the crutch of our organization from a storage perspective, since the early 90s. So what we decided to do was determine how can we protect those read-enhanced SSDs? What can we do? What can we leverage technology-wise? We came up with this algorithm called in-lift cache, and this is how we protect the SSD endurance. So over on the right-hand side of this screen, you see 2 blocks. The top one is the read and writes from the SSD tier. So this is just very standard. If a write comes in, which is considered Y at the top, and it's going to come in and it's going to land inside the write tier. So it's landing on those enterprise SSDs. If a read request comes in, that read is going to be sitting in the read tier. That's block Z, the blue block. It's going to be served up and read out of the read tier. So the read goes out. Very simple logic. Now, what happens if a change comes to the Z block that's sitting in the read tier? So if you see the bottom picture here, the read tier protection with in-lift cache. So when a rewrite request comes and it's for block Z, it's checked against our map and we know that block Z resides in the read tier. Instead of sending it downstream to the read tier and letting it change that block, we actually store it in in-lift cache. So in-lift cache is a small portion inside the write tier. It's a buffer, basically, where we send those rewrite blocks, and then those rewrite blocks are gathered together in that in-lift cache, and we make one consolidated write downstream to the read tier. So that's how we use the 1 drive write per day read-enhanced SSDs, and we don't wear out the SSD endurance. As a matter of fact, when we sell a StorTrends 3600 AFA, we guarantee the endurance for 5 years. So for 5 years, you will never run out of endurance in these drives. You're not going to have a problem with it. We guarantee it, and we replace those drives if anything ever happens from an endurance perspective. But this was one of our major concerns in designing an AFA. If we chock this thing full of SLC drives, enterprise class drives, it's going to be so expensive that a lot of our customers can't purchase it. But if we put read-enhanced SSDs like some of the other vendors are doing, you're going to blindly hit endurance issues in year 3, year 4, year 5. What happens if you hit those endurance issues? How do you replace them? If you're writing evenly to those drives and you're using wear leveling and you're monitoring the garbage collection process, those drives should all expire around the same time. So when they all get to 5 to 10% endurance left on their life, how do you replace 24 drives in an array? Do you just replace them one at a time and let them rebuild? So for the next 24 days, you're going to be replacing a drive inside your infrastructure? Or is that vendor going to ship you a new array and make you replicate off of it to another? How do they plan on replacing those drives when they run out of endurance? This was a main concern for us here at StorTrends, and this is why we implemented this patented algorithm called Enlift Cache, so we can guarantee that they're not going to run out for that 5-year period. So with these technologies, and with our experience based in storage for so long on RAID, we've been able to figure out a way to provide you with an all-flash array at a lower price point, bringing you more value, so you don't have to break the piggy bank. So this is where the rubber meets the road. So let's look at a diagram here of an all-flash array versus a hybrid SAN array. So we're going to just compare them head-to-head here. So let's say that the end customer has a 30 terabyte usable capacity requirement. So on the right over here, you'll see our red or orange block. This is the StorTrends 3500i hybrid SAN. We're going to sell them a raw capacity hybrid SAN of 63.3 terabytes. The configuration for that box is 2 200 gig SSDs in cache, 4 800 gig SSDs in the SSD tier, and then 10 6 terabyte NL SAS drives in the spinning disk tier. Now we're going to put those NL SAS drives in a RAID 10, because in the event that you move too much data, you migrate too much data, you run into any kind of an SSD miss. If your tier becomes full and you outgrow it, we want you on RAID 10 coming off of those spinning disk drives in the back end. We don't want you on a RAID 5 or a RAID 6 because it's going to be extremely slow. So we want to try to get you the best protection that we can. This is the way we would configure and sell a hybrid solution like this. So at the end, you're going to net a usable capacity of 29.47 terabytes. Now, we do not support deduplication or compression in our hybrid arrays because of the overhead involved with them. Both dedupe and compression have a severe overhead on performance, and anybody that tells you any different is not telling you the truth. Those overheads impact the array so much that we couldn't put them in our hybrid SAN. It would overload the capacity. You would end up with a hybrid SAN that would only serve up a few thousand IOPS, and it would suffer tremendously. So you have to be very selectable about dedupe and compression when you put it on a hybrid SAN, and you have to be very cautious if someone's trying to sell you that on it, because you may buy it with dedupe or compression, and then you'll find that you'll never actually use it because it's such a performance killer. It creates so much bottleneck and overhead that it causes your applications to drag and be slow. So what do we net from a hot data perspective in this hybrid SAN configuration? You're going to have 2.88 terabytes of hot data. So the industry average is about 10%. So you can see here our hot data is 2.88. Our overall usability is 29.47. We're right there at 10%. We're about 9% of our data is in hot data. The latency is going to be somewhere in that 3 millisecond range. IOPS, if you did an IOP calculation, this box would push about 100,000 IOPS. And that's, again, since we don't have dedupe and compression in the box. If dedupe and compression were enabled, that number would drop significantly. It's a 3U box. Yearly power is about 5,028 kilowatts per year. The CO2 emissions, it's about 3.5 tons of CO2 emissions. So the list price that we sell that box for today is $64,999. The street price that a customer would purchase it for would be somewhere around $35,000. We put $35,888 here in. So if you take $35,880 and you divide it by the 29.47 usable capacity for the hybrid array, it comes out to $1.18 per gig, so $1.18 per gig based on usable capacity. Now let's shift our focus to the left into the green block. This is the StorTrends 3600 all-flash array. So the raw capacity of this array is 12.3 terabytes. The configuration there is 4 400 gig write tier drives, that's our enterprise class write tier drives, and then 12 960 gig read tier drives. So there's our read focused drives. So the usable capacity here is going to be 30.6 terabytes. So how did I get that? How did I go from 12.3 to 30.6? Our dedupe ratio is 2.6 to 1. That's a low average for us for our typical 3600i installation. A lot of our customers get into the 4 to 1 ratio, but we wanted to provide a low number here and not a marketing gimmick number for you. As I indicated earlier, the compression ratio, when you turn compression on, you're going to see a 0.7 to 1 ratio, so we've got our 0.7. So when you add your 7 to your 2.6, you come up with a 3.1 data compaction ratio. So 12.3 after RAID multiplied times 3.1 gives us our 30.6 terabytes of usable capacity. So how much of that's hot data? It's all hot data. It's an all SSD array. So now we're comparing 30.6 terabytes of hot data on the left in the all flash to only 2.88 terabytes of hot data on the right in the hybrid array. Our latency now has dropped from 3 milliseconds down to 1, and our IOPS increased to 200,000 because now we have all SSDs. There's no spinning disk in this array. It's a 3U. It uses less power because it's all SSDs. SSDs draw less power than spinning disk. So there's going to be about a $1,500 savings. It depends on your kilowatt rate, but there's about a $1,500 savings in running the all-flash array from an OpEx perspective when you're talking about writing a check to the power company for operating the 3600 over the 3500. And then the CO2 emissions, you're talking about 2.3 tons versus 3.5 tons. The list price is $66,999, so just $2,000 more than the hybrid. The street price is $36,984. If you take $36,984 and you divide it by your 30.6 terabytes, it comes out to $1.18 a gig. So here you can see you can buy a hybrid array from StorTrends today at $3,500 for $1.18 a gig, or you can buy an all-flash SAN array for $1.18 a gig. So this is where the rubber meets the road. This is primarily due to 3 components. How do we make this pricing happen? 1 is the dedupe and compression technologies. 2 is the write tier and read tier mixture ratio that we've been able to architect with the in-lift cache, the patented in-lift cache technology. And 3 is the relationships that we have with the SSD vendors and able to get the right SSDs in the box in order to bring that price down so that we can meet or match the same prices as hybrid arrays in the market today. Now, you can take this and the hybrid slide that's over there on the right, you can replace that with any other hybrid vendor you want. It's going to be more expensive than that. Typically, when we compete head-to-head against the other hybrid manufacturers in the market, we're usually about 10% cheaper than they are. So you can see that the all-flash SAN array is going to even be cheaper than the hybrid arrays you probably already have quotes in hand for today. So if you're interested in obtaining a price quote, let's say that, yeah, I'm interested. I'm wanting to check this thing out. I want to know what my actual price would be on my array. You can go to our website. You can configure your all-flash storage array on StorTrends.com. You can receive a price quote on the configurations you select. So when you open up the price quote page, if you'll go to the Contact Us button, there's a price quote generator there. It's an online price quote generator. You select the capacity, you select the max ops, you select your interface type, your read-to-write ratio, your application type, your support level, and your support term. And once you select those pieces, you hit submit, and you're going to receive a price quote via your email address that you put in. So if you're interested in obtaining a price, you can go there and fill that out, and you'll be provided with a price on a 3600i or a 3610 all-flash array. So let's spend just a couple minutes here talking a little bit about StorTrends. So who do we sell to? There's thousands of these systems deployed worldwide in all different types of verticals. We don't target a specific vertical. Now, I could say that we do. We work with a lot of the radiology companies here in America, and we know that the application that they use for the radiology purposes, and we're tuned with that application, but we don't target that. We target all types of different verticals. Basically, the way we look at it, anyone looking for centralized storage or secondary storage that's in the need from a few terabytes up to 256 terabytes, that's where we play. So we have a multitude of customers in educational, financial, healthcare, legal, retail, service providers, you name it, we've got them. Here's just a really quick snapshot of some example end customers. Again, thousands of these installed worldwide in both the SMB and the SME markets. Some of these names that you probably know of customers on here, some you may have never heard of. But just want to show you all the different markets that we actually fit into for centralized storage. So this next slide here, this is the DCIG rankings. They just released their all-flash array just a few weeks ago. You can see here that we placed in the excellent realm. So best in class was the HP 3-par StorServe, then the HP 3-par 7000 series, and then the NetApp AFF 8000 series. So we're not offended placing fourth on this list. We think we're in pretty good company. Those are companies that have been around for a long time. They've been in the storage industry for a very long time, and we're proud to be included in this list. Just the thing that I want to note here is not only did we place excellent among the 28 AFA products that were, that were recognized, we were number 2 on the sub 100 list. So we were number 2 behind the Pure Storage array. If you'll check our prices versus all of these others, you'll find that there's a significant price savings in choosing StorTrends. So that's something that we pride ourselves here on. Our CEO has always been focused on price points for our end customers, even in the raid days. We wanted to make sure that we were providing a quality product with quality value. So it's just something that's in our DNA here at AMI that's been, blessed in this company for a long time. If you'd like a copy of this report, you can download it off of our website. You can get a complimentary copy, and you can read on every one of these arrays that's in the report, some of the good things, some of the bad things from each one of these arrays. I would highly advise just go check it out and download it. So let's talk just a little bit about the technical aspects of StorTrends. So we've talked about hybrid SANs, we've talked about all-flash SANs, we've talked about the pricing differences between the two. So basically now you're at a point of, okay, if I can get an all-flash array, why would I buy a hybrid array? That's what you're thinking to yourself. But let's check out some of the pieces of the StorTrends all-flash array. So first and foremost, inline compression and deduplication for superb space savings. In our architecture, we've actually created, this is highly patented, it's something that's very unique in the industry. Most companies have one deduplication table that they use for a lookup, and what we found in studying this in-depthly is that you can get by with 2 dedupe tables. Your first dedupe table, what we call our top, that's our hot table. The second dedupe table, which we call our bottom, that's our cold table. The hot table sits in system memory, the cold table sits on the SSDs. So we found that about 98% of the time we can do all of our lookups, our hashing, and our data compares in the hot table. If you think about a hybrid array, an all-flash array, or any type of an array like that, your last written data is your most frequently accessed data. So the data that was written to the array just now is going to be probably accessed more than anything that was written 3 weeks ago, 4 weeks ago, 5 weeks ago. That's just common practice in the way that data is written and the way data is read. So why would we want to store a huge lookup table and have to hash through all of those lookups and those tables up top and take time and create delays when we could take and just extract the hot data that you've written and store that in that lookup table? Now, there are times, and I said it's 98% of the time we play in the top. 2% of the time we have to go downstream into the SSDs and pull that bottom table, and that does create a little latency. But 98% of the time, we're able to create those matches, those dedupes, and those lookups in that top table. So that allows for a very fast and efficient deduplication engine. And then our compression. Something that we do a little different than other vendors, we only compress once. A lot of vendors will compress, dedupe, and compress. We found it more efficient to dedupe, then compress, then write, and we're done. So this is a very highly patented technology, the way that we've done it, and it allows for superb space savings. Second on the list, read and write optimized flash tiers. So we talked about read-intensive and write-intensive flash tiers. Then we talked about inlet cache, how we extend the SSD endurance and the performance with inlet cache. We have over 100 different configurations to meet performance, capacity, and price. So if you go and fill out that price quote generator, or if you decide to speak with one of our reps, there's over 100 different all-flash configurations. A lot of other vendors, they only give you 5, 6, 8 configurations to pick from. They try to paint you into their box. We want to give you the full flexibility of what you need. So we can mix and match these read tier drives and these write tier drives to accommodate exactly what you need from a performance perspective, a capacity perspective, and a price point. And then featured-based licensing. We're an all-inclusive model. So we don't have individual license price points like others have. It's all-inclusive. And then complete VMware integration. So we support VAAI, all of the primitives, both the mandatory and the optional. And then we talked a little bit about the superior latency in the sub 1 milliseconds. The value here, the data compaction configurations, with those we can range $1 per gig is our average for pricing the all-flash array. And the applications that we target are high-performance databases, mixed workloads, VDI environments, and virtual environments. And then you can see over here on the right, this kind of gives you a real quick snapshot of some of the main features. Obviously, deduplication and compression. We have advanced snapshots, our in-lift cache. We have a really, really neat replication package. We do RAID RT from a software RAID perspective. We do have automated data tiering in here, and then thin provisioning. So there's a multitude of features that are included with the array. So this slide talks a little bit about the evolution of the StorTrends product models. You can see on the left here, this is the spinning disk array. In the middle is our hybrid 3500i array. The hybrid array was released in 2013. The 3400 was released in 2007. The 3600 and 3610 are our all-flash array models that we're talking about today. So the only difference in those two platforms, the 3600 scales up to 64 terabytes, and the 3610 scales up to 256 terabytes. If you're an end customer that only needs 10, 20, 30 terabytes, 40 terabytes, and you're never going to grow beyond that point, we created a slimmer package in the 3600. So it's 16-core CPU, 64 gigs of memory. That allows us to lighten the load of the CPUs and the memory so that we can provide a more value in that product to you. It's not as expensive as loading up the 3610 with all of the cores and the memory to reach that 256 terabyte price capacity point. So the 3600 is made for customers that are going to stay under that 64 terabyte capacity limit, and the 3610 are for those that need to expand up and grow out as their business grows and as their capacity grows. This is kind of an eye chart, but I just wanted to flash it really quick. Just wanted to hit a couple points here. We're VMware certified, we're Citrix certified, Microsoft certified. We're working with Red Hat now on RHEL. So if you're using any 4 of those virtualization platforms, layers, we support all of those. We have plugins for those. We talked a little bit about our advanced snapshots. We talked about, we've got a replication package in here. With the replication comes wide area data services. So we can do deduplication, compression, encryption, and we perform WAN optimization when replicating to the secondary site. So that's a really neat package that's kind of baked in there. And I'm going to skip some of the rest of these because we're starting to run a little close on time. Just want to stop here and talk about the StorTrends iData tool. This is the tool I was telling you about we had to implement and create when we launched our hybrid storage arrays. So this thing runs for 7 days in your existing environment. It sets up in just a few minutes, and it utilizes the existing performance tools in your environment. It doesn't have any load. It's non-intrusive. At the end of the day, this thing's going to roll up a summary report like you see on the right here in the screenshot. It's going to provide your capacity, your ops, your region rights, your network utilization. It's going to tell us what your bandwidth is. The main thing is it identifies your hot or active data versus your cold data. And that allows us to know how much SSD space we need to put versus HDD space. This is the primary tool that we use to ensure that we made the right product configuration and the product placement when we were selling hybrid arrays into infrastructures. The next tool, StorTrends Dedupe Analyzer, this can be downloaded from StorTrends.com as well. This runs on backup or unmounted data. You cannot run this on a mounted database. So if your database is currently connected, you have to either disconnect it or you have to run it on a backup copy. The reason is it generates an I/O load. It's stepping through the data blocks that are sitting there, and it's looking for comparative data blocks for dedupe savings. So you don't want this to take place and run on your production environment while it's up. If you have a maintenance window, it's something that can be ran. It doesn't have to be ran on an entire volume or an entire database. It can be run just on a very small subset of that. All we need is a good indicator of the number of blocks that we're going to be able to dedupe, and then it'll produce that calculation. So it's going to tell us what your data compaction ratios are going to look like and give us an indicator of where you're going to be. And that's how we place the right number of SSDs for the right tier, read tier, and the right sizes of those drives in your infrastructure. So now we're going to jump over into a live demo here. So this is the StorTrends 3600. This is what you originally see when you log in. You'll come to a prompt page. It'll ask you to give a username, password. You log in through any web interface. It could be Google Chrome. It could be Firefox, Mozilla, anything like that. Once you log into the IP address, you put your credentials in. This is the first page that populates. So you can see that there's a wealth of information here. You've got your storage statistics. So here's the physical capacity of this box. It's a 4.55 terabyte box. The predicted capacity based on the usable data on it now is 26.06. So what does that mean? That means that we're getting a data reduction ratio of 5.7x. So you can basically assume that the 0.7 is our compression, and you're getting a 5-to-1 dedupe ratio on the data that's on this box. So this is one of my lab boxes. You know, I've got a lot of different data sitting on this box. I'll show you some of the volumes in just a minute. It's basically set up for demos and just to run IO load across when I'm showing a demo like this. But that database is showing somewhere around a 5.0 dedupe ratio. So it'll show you how much predicted free space you've got. It'll show you your physical space. This page is also the main home page for the array that allows me to see kind of what's going on. So there's no critical or warning events that have came in. We can refresh this and it'll show us if there's anything that's popped. We track smart errors in our disk. So some of you that are wondering about the endurance, we've worked really closely with the drive manufacturers that we use for this array. And we've incorporated their tools into this and hooks so that we can pull the endurance levels and all of the smart attributes out of that drive. So we can tell you with just a real quick click, and I'm going to go down here and go ahead and click on it. We can pull up the disk smart analysis here. And this is going to show you what type of disk are in it. So I can just hover over one of the devices. This is slot 5 in the array. And then this is where it's going to give me all my information. It tells me what my serial number is. It's going to tell me the firmware revision, so I know the last time the firmware was flashed. We can flash the firmware on the fly, by the way. It's going to tell me the size of the drive. It's going to tell me the rotational rate. It's going to give me all the details that I need, or actually that a support rep would need, in the event that they're looking at this drive. But it's also going to give us the indicator of the percentage of the endurance left on the drive. So I can go through this and show you that the percentage rate is 100%. You can see it there. So let's go back up to the top here. And we track all of that stuff inside of this array, and we're hooked into all the statistics. Sorry, I'm trying to do RDP here, and it's not letting me grab my mouse. Come on. Okay. So we track all of these neat statistics in the drives, and then we can feed that back. And then anytime that there's a problem or an endurance, it's going to warn you right here and give you a warning. Then you'll click on that smart page, and you can immediately see what's wrong. As we move down this initial statistics screen, it's going to show us performance. So we can see our latency. You can see the different points in the latency here. You can highlight on them, and it'll bar graph them. You can see this is live. It's actually moving. So the blue is my read rate latency in milliseconds. The green is the write latency in milliseconds. So you see we're at 0.31, 0.4. We're all sub 1 sitting here on this array. So then you can see your ops. These are your read ops versus your write ops in the green. You can see the true statistics of the array. As we move down, here's our throughput. You can see IO distribution. This is all 8K that I'm running on this box right now in the reads. And you can see that the writes are kind of carved up with the vast majority being 4K writes. And then this is my average read-to-write ratio. So these are live statistics that are coming in the box. Now this is from the storage pool perspective. Now we can click on the volume stats, and we actually can dive into these volumes here. So you can see how much of the mapping capacity you've got. You can see your snapshot capacity. This gives you a good idea of what you're actually using in the array. And then all of your different volumes. So you can click on one of these volumes. Excuse me. And below, it'll refresh the charts. And we can kind of get an idea of what's going on in this box, right? So we had a latency spike right here. I was actually moving some data a little earlier on this box to be able to show a load on this box. So you can see where it spiked up here when I added that data, but it went to a 0.25 latency. So this box is screaming fast right now with the data load that's sitting on it, specifically on this volume. So let's keep moving along here. Let's kind of jump into the event log. This is where we log everything that happens in the array. So this event log is also transmitted to our storage support team. So we have 24/7 support out of Atlanta, Georgia. When you call, you're going to receive an answer from an engineer here in Atlanta. You're not calling anywhere else in the world to get any other kind of support. And we do our support a little different. What we do is we hire engineers to do our support. We don't have help desk technicians or anything like that. These are people with computer science degrees, electrical engineering degrees. Most of them have been in a support role for a long period of time. So these guys understand what it takes to get your unit back up. You're not going to a help desk person and then being transferred to a level 1 tech, a level 2 tech, a level 3 tech. We cut all that out. We find that it's a lot easier for you and a lot easier for us if we just allow you to speak directly to an engineer that can get you back up and going no matter what it be, whether it's a drive that's run out of endurance, a controller that's for some reason failed over, or just a question that you may have about a configuration or a setting that you want to change in the array. But these events are logged locally in your box. You can choose to export those events to us, and we'll monitor those events 24/7 live. Most of the time, we actually contact the customer before they've realized something's happened in their array when we're monitoring these events. The next tab here, let's just jump into the hardware health. This is a really cool view of the box. I know of no other GUI that provides anything like this in the industry. This just gives you a real-time view of what's happening in the box. So you can click on one of the drives. It'll tell you what kind of drive it is. This is a read-intensive drive. It'll tell you the space on the drive. It'll tell you the slot number. You can click over any of the CPUs or the fans. It'll tell you if they're okay. It'll tell you the voltage. It'll tell you the sensor values. You can click on the rear view. So if you have a network issue, right, so like you see this little red thing here, it's telling you that this NIC's down. So I went and unplugged it before this demo. I wanted it to throw an event, and I wanted it to show red. So you can see my network's down. So you can quickly log in from home or wherever you're at and say, okay, I do have something going on with this NIC. And in this case, this controller would have failed over to the other controller because it actually lost, one of the team NICs. So to improve your throughput, we would have failed this thing over. And then if you have additional enclosures underneath this box, you can click here and it'll show those additional enclosures underneath here. You can just click on those and manage them. Back to the other piece of this thing, at the very tip top here, if you have multiple boxes, the storage boxes in your infrastructure, you can click on them. You can immediately log into them and manage them from one screen. So we have a multitude of features baked into this thing that really allow you for easy management. It's a really slick GUI. The thing that I want to point out here really quick at the bottom is everything is configuration wizard driven. So we recognize that you don't spend every day inside of this box. This is something you set something up, you want to forget about it until you need to make a change, until you need to add more VDI users or whatnot, or another volume. So everything's wizard driven. We don't expect you to remember all the nuances in managing this box. So we try to make it as simple as possible. You want to create a volume. It's just a really quick process. You just go to the volume wizard. You can see that it's 3 simple steps, and we guide you through everything. And if you make a mistake at any point in time, it'll error it out. It'll tell you what the mistake is, and it'll tell you a suggested fix for it. So it's a really easy product to use. So now I want to go back, and I want to show you the plugin really fast here. So most of you are familiar with vSphere, I'm sure. About 90% of our customers use VMware. They may use VMware with Hyper-V, but they're predominantly VMware or VM shops. So you're probably very familiar with this screen in the vSphere web client. If you are, we have a plugin for it. So this is what the plugin looks like. So you can click on the summary tab in the plugin. You can see this is a 3600i. Here's my system name. This tells me everything that's on this box. So you can see here's my inventory list that it pulls up. So everything's listed here that you need to know about the box. We can go to the storage statistics tab. Now I can start jumping into what it's doing from a latency perspective. I can click on it, move it around. If I want to get granular with it, I can go to my volumes. Now you can see I've got 3 virtual machines running here. I've got a firewall, then I've got a JB initiator and a JR initiator. You can click on this. You can hit either auto refresh, and it'll refresh once every minute, or you can hit a manual refresh. And this thing's going to come back up, and now it's going to show me all those different VMs that are sitting there. It's going to give me their latencies. It's going to give me their ops. It's going to show me the throughput. It's going to show me the volume IO distribution on both the reads and the writes, and it'll show me the block sizes that are coming in. So we can dive deeper into these charts, and what it helps me do is understand where there could be a potential bottleneck. So if there's anything going on with that VM, I can dive into that and understand more about what it's doing, how it's doing it, and why it's doing it. And then if you want to manage the array, you just click the Manage tab. So here we can do a virtual machine creation. We can load a template. We can do virtual machine cloning. We can do a data store expansion. And then we can also do a data store deletion. If you want to add a snapshot, take a manual snapshot, adjust your snapshot schedule that you already have set up. The snapshots are based on volumes. Everything can be done here from this one screen. So total management of the array from within vSphere, it allows you to manage it without having to actually go outside of vSphere. You can live here if you'd prefer to manage it from here with our plugin. So with that, I'll turn it over to Tyler now for the last couple minutes here.
Awesome. Well, thanks so much, Justin, for that deep dive. Everyone, hope you had a great time today at the virtual Lunch and Learn. We're going to run through, since we only have about a minute or 2 minutes left here, going to run through some quick questions that we got. We got a couple of these multiple times, so just want to address these very quickly before we get you guys out of here today. One is, does StorTrends offer evaluation units for testing purposes before any sort of purchase or buying obligation has come about? And the answer is yes, absolutely. StorTrends offers what's called proof of concepts for our all-flash arrays. It's a very simple 3-page document. There's really no obligation at all. We'll send it out to your environment. The only thing we ask is that you don't beat this thing up with an actual literal hammer while it's in your possession. Other than that, we want you to test it in your environment, make sure it works with your data and works well within your environment, and test it in your environment for about 30 days. And if at the end of 30 days you like it, you're more than welcome to keep it. If not, just send it back, and there's no hard feelings there. And we have about a 97% success rate with our POCs, so very good success rate. And people usually like our all-inclusive feature sets, our GUI management, and of course all of our technical support that we go into. So that was one quick question. Another question we had was, can a 3600 replicate to other types of devices that are made by StorTrends? In other words, can a 3600 replicate to a cold DR site that has a 3400 all-spinning disk array or a hybrid array? And the answer is yes, absolutely. We're one of the very few, if actually the only vendor that I know, that can actually replicate from one of our higher performing boxes to a lower performing box. That way you don't actually have to mirror, the same all-flash array in one environment that you do at the other. So you're saving a lot of cost there in flash technology when you may not need that extra performance at the secondary DR site. Looking at it, one quick question that I think Justin might have a little bit better grasp on, and we addressed it a little bit during the call, just want to make sure we double address it, and that was when do you expect the SSD endurance to run out for one of these arrays?
Yeah, so that's a great question. That's a question that a lot of customers have. When we're in contact with them and pitching them our all-flash arrays. So this was a major concern for us that a lot of vendors don't talk about, or that they don't want to educate the end customer on. So, that's an excellent question. What happens in year 3, 4, 5, 6? We guarantee that the drives will not have any endurance issues for 5 years. We do that with the read and write to your mixture and then the in-lift cache that's baked into this box. So that allows us to ensure that we do not use those cells up in that 5-year period. So, obviously, we've done tests here internally at AMI where we've gone through and ran these drives and forced so much data on them in a write scenario that we've tried to break them over a period of time. And I can tell you now that the endurance, the way that we're handling it with in-lift cache, it takes a long, long time for the endurance to run out. So it should be well over 5 years before these drives actually have any type of an endurance issue.
Very good. Thanks so much, Justin. Just last 2 quick questions, and we'll wrap it up here. What is the price of a StorTrends 3610 with 150 terabytes of all flash? If you want to know the price of any particular array regarding whether it's all flash or any other type of device and at any sort of capacity, the best thing to do would be go to StorTrends.com. You'll actually be routed there once you exit out of WebEx, just in case there's anything you want to browse or look at. You'll be routed there after this event, but you can also find the price quote generator under the Contact Us tab. There you'll see the price quote generator form fill, and you can fill that out, put in your specifications, how much capacity you're looking for, what sort of applications you're running, all that kind of stuff, and then we'll send you a no obligation quote just to kind of give you a good ballpark estimate for what you can expect the price to be. And last quick question we had, and we'll wrap it up, and thank everybody for coming, is somebody said, I have a split environment with both VMware ESXi 6.0 and Microsoft Hyper-V. Do you support both environments? The answer is, of course, yes, absolutely. All of the StorTrends arrays are certified with both VMware and Microsoft, as well as Citrix. StorTrends is a TAP Elite partner with VMware and a Gold partner with Microsoft. We've supported and been full partners with them for a very long time and are very well in tune with both those virtualization technologies. Other than that, that's all we have for you. If you have any questions after the event, anything you thought of that you didn't get quite a chance to answer or get a chance to ask, feel free to shoot those over to me. Everybody still has my email, tylerin@ami.com, and we'll be happy to answer anything we can for you. Get in touch with us on the website, and we'll be happy to help out any way that we can with your virtualization questions or anything like that. Other than that, this is Tyler Newberry with StorTrends team. Justin, do you have anything else for the people before we sign off?
Thank you for taking time to spend with us today, and we appreciate it.
Awesome. Thanks so much, everyone. Hope you enjoyed the pizza, and we look forward to talking with you in the future. Bye-bye.